In this video, we will solve question number 36. Here, G is a group and ZG is the center of group G. In option A, it is given that if G is non-abelian and ZG contains more than one element. Suppose G is Q8 and elements in Q8 are 1 minus 1, I minus I, J minus J, K minus K. Okay, and center of this group Q8 is 1 and minus 1. Only those elements are commute with all other elements of this group, means all elements of this group Q8. Okay, so minus 1 and 1 are the only elements of the group ZQ8, and order of the group Q8 is 8 because there are 8 elements of this group, and ZQ8 is 2 because there are only 2 elements in this group. So D by ZG, so this is equals to Q8 by ZQ8. Okay, so this equals to, we can write this like that, order of Q8 by order of ZQ8. So this equals to 8 by 2. So this equals to 4. That means in this group there are only 4 elements. Okay, but it's not equals to 1. So they say that there are only one element in this group. So option A is incorrect. Okay. In option B, if order of G greater or equals to from 2, then there exists a non-trivial homomorphism from G to Z to G. Okay, so suppose order of G greater or equals to 2. Suppose G equals to Z2. Okay, suppose G equals to Z2, and then there exists a non-trivial homomorphism. Suppose phi is a homomorphism from Z to G, the G equals to Z2. Okay, and the normal subgroups of this group Z are Z, 2Z, 3Z, 4Z up to infinite. Okay, so now ZYZ is isomorphic to the identity group Z1, which is subgroup of any group. So this is subgroup of Z2, but this is a trivial homomorphism. Okay, so now Z by 2Z is isomorphic to Z2, and this equals to this Z2 group. So this is a non-trivial onto homomorphism. This is a non-trivial homomorphism. Okay, so option B is correct. There exists a non-trivial homomorphism. Okay, so option B is correct. Now option C. In option C, it's given that if order of G greater or equals to 2 and G is non-abelian. Suppose option C, suppose G is Q8. Okay, this is a non-abelian group and order of this group is 8. This is greater than from 2 and this is non-abelian group. Okay, and they say that there exists a non-identity isomorphism from G to itself. Suppose phi is a non-identity isomorphism G to G, means Q8 to Q8. Okay, so this is a non-identity isomorphism. Non-identity means non-identity. Non-identity means suppose from G to G, there are a function phi. The elements in G is -1 and 1 minus 1 and 1. Suppose minus 1 maps to minus 1 and 1 maps to 1. Okay, so phi minus 1 equals to minus 1 and phi 1 equals to 1. Okay, so phi x equal to x here. Here phi x equal to x for all x belongs to the group G domain. Okay, so this is called identity mapping from phi is identity mapping from G to G. It's phi. And non-identity is, suppose from the group G to G there is a function from G to G phi. Suppose the number of elements are minus 1, 1 and 2, minus 1, 1, 2. Okay, suppose minus 1 maps to minus 1, 1 maps to 2, 1 maps at 2 and 2 maps at 1. Okay, so here phi minus 1 equals to minus 1, phi 1 equals to 1 and phi 1 equals to 2 and phi 2 equals to 1. Okay, so here phi 1 not equals to 1. So here phi x not equal to x. That means phi is a non-identity mapping. Okay, this is called non-identity mapping. And here phi is isomorphism. Isomorphism means phi is 1 1 on 2 and homomorphism. Okay, first I will check phi is 1 1. Okay, so suppose phi x is, here phi is non-identity. That means phi x not equal to x. So I will take phi x is 1 by x. Here this is not equal to x. That means phi is non-identity. Okay, so first condition is correct. That means phi satisfies this first condition. And now I will check phi is 1 1 and then on 2. Here phi x equals to 1 by x. Now I will draw a graph phi x. This is x-axis, y-axis, and this is origin. The graph phi x equal to 1 by x is this. Okay, when x tends to infinity, y tends to 0, and x tends to 0, y tends to infinity. X tends to 0 plus, y tends to infinity, x tends to 0 minus, y tends to minus infinity, x tends to minus infinity, y tends to 0. Okay, and now if I draw a straight line which is parallel to x-axis, then it will be cut this graph phi x equal to 1 by x exactly at one point. Okay, if I draw infinite number of graphs, infinite number of straight lines which is parallel to x-axis, then these straight lines cut this graph at most one point. Okay, at most one point. That means the phi x equal to 1 by x is 1 1 at most one point, because if you draw a straight line which is parallel to, which coincide with x-axis, then this straight line, it does not cut this graph 1 by x, phi x equal to 1 by x. Okay, then all of those straight lines cut this graph at most one point. That means phi is 1 1. Okay, now I will check phi is on 2. This is the graph phi x equal to 1 by x, and if you take the projection of all of those 1 minute, the graph is like that. sorry. Okay. If you take the projection of all of those points, this of this graph on y-axis, this is y-axis and this is x-axis. Projection of all of those points of this graph on y-axis, then the projection is minus infinity to infinity except 0. Okay. It is possible when the phi is a function from real number to real number, but here phi is q8 to q8, q8 to q8. Okay, phi is q8 to q8. So the projection is not minus infinity to infinity. Okay, so I will draw again this graph. This is y-axis, x-axis, x-axis, y-axis, and the graph phi x equal to 1 by x is this. Okay, and here phi here phi is such that q8 to q8. Okay, and elements in q8 are plus minus 1 means 1 minus 1, I minus I, j minus j, and k minus k. Okay, so phi x equal to 1 by x. So phi, if you take x equal to 1, then it will be 1 by 1 means 1. If you take phi minus 1, then it will be minus 1. If you take phi I, then it will be 1 by I. Okay, and if you multiply at numerator and denominator by minus I, then so not minus I, then it will be I by I square. Okay, I by I square is minus 1, so this equal to minus I. So phi I equal to minus I. Automatically phi minus I, it will be I. Okay, so the here the coordinate is 1 comma 1 point is here 1 comma 1. Okay, and here the coordinate is minus 1 comma minus 1. The point is here minus 1 comma minus 1. Okay, and the point I comma minus I comma minus I. Oh wait, yes. Suppose the coordinate of the point I comma minus I, actually I can't plot this point I comma minus I in this graph, because I is a irrational complex number, and minus I is similarly a complex number. So in x-axis there are all real points. Okay, suppose I and minus I is here, and j minus j is here, k minus k is here. Okay, if you take the projection of all of those points on y-axis, then the points are this. Okay, this, okay, so these points are 1 minus 1, I minus I, j minus j, and k minus k. And so this is the range of the function phi. Okay, range, sorry, not r, range, and this is q8. So range of phi is q8, and here codomain is, this is codomain is q8. So range equals to codomain, that means phi is a onto function. So phi is 1 1 and onto non-identity, and now we'll check phi is a homomorphism. Okay, here phi is a here phi x equals to 1 by x. Suppose x1 and x2 are 2 points from q8. Here phi is a function from q8 to q8. Here domain is q8, codomain is q8. Suppose suppose x1 and x2 are 2 points, 2 elements from the group q8. x1 dot x2, phi x1 dot x2. Here I take the operation q dot, because in this group q8 the operation is dot. So phi x1 dot x2, it will be 1 by x1 dot x2. Okay, so this equals to, I can write this like that, 1 by x1 dot 1 by x2. So this equals to phi x1 dot phi x2. Okay, so phi is a homomorphism, that means phi is a, this implies phi is a homomorphism. Okay, so phi is also is a homomorphism also. So this is a correct example for this option. And they say that if g order of g greater or equals to from 2, q8 order of q8 is greater or equals to from 2, g is non-abelian, q8 is non-abelian, and there exists a non-identity isomorphism. Okay, it's a non-identity isomorphism. It's I will yeah, non-identity, because the function phi x equal to 1 by x is not equals to x, that means it's a non-identity. Okay, and it's an isomorphism, 1 1 onto homomorphism, that means phi is isomorphism from g to g itself, q8 to q8 itself. Yeah, there exists an isomorphism like that. So option C is correct. Okay, now option D. In option D, order of g equals to p cube, and p is a prime number, and g is necessarily abelian. No, it's not true. It's not true. Option D. Order of g equals to p cube, where p is a prime number. But it's not, and they said that g is abelian. Suppose g equals to q8, so order of g equals to order of q8 is 8, so this equals to 2 cube, so here p equals to 2, which is prime. Okay, So the example G equals to Q8 satisfies this given conditions. But Q8 is non-abelian group. So the statements are wrong. So the statement is wrong. Okay. Option D is incorrect. Here option D incorrect, A incorrect, only B and C are correct options.